we live in a country with a failed educational system.
Ooh, that one hurt. That one hurt. That one hurt.
And the only thing that makes a perfectly circular shadow
would be something that's perfectly circular.
Perfectly spherical.
Spherical. Right.
Yes. And the only thing that makes a perfectly circular shadow
would be something that's perfectly circular.
Perfectly spherical.
Spherical. Right.
Yes. And the only thing that makes a perfectly circular shadow
would be something that's perfectly circular.
Perfectly spherical.
Spherical. Right.
Yes. Gay! Our system needs to train you not only what to know, but how to think about information and knowledge and evidence. If we don't have that kind of training, you'd run around believe anything.
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 Right now, we only can fly in Earth orbit. That's the farthest that we can go. Right now, we only can fly in Earth orbit. That's the farthest that we can go.
So tell me, Neil, is the Earth flat?
We have video from space of the rotating spherical Earth. The Earth is round.
Thank you for joining us on this episode.
What's odd is there are people who think Earth is flat,
right?
But recognize that the moon is round. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and the sun are all spheres, but Earth is flat. That's not, something doesn't square.
Something doesn't jive, right?
Okay. Plus, in my latest book, ooh, did I just plug my book?
Wait, your latest book is called Astrophysics for People in a Hurry. What? We just happen to have a copy right here.
No, it just happens to me. I swear we didn't plant the book. I have an entire chapter titled On Being Round. Gay! And it's an exploration of how all the laws of physics and the accounting of energy as processes unfold in the universe, how that conspire to make things round.
So it favors the sphere.
Favors a sphere, yes.
Right.
And if something's not a sphere, it's a little bit flattened, you can ask what flattened it, and you find out, oh, it's rotating real fast.
Right.
So then it gets a little flattened because of that.
Right.
And so almost everything in the universe is either spheres or slight distortions of a sphere for some other thing that's happening to it. I mean, we can just see how the universe favors spheres.
So it's nature.
Right.
Basically,
nature.
the universe.
In all fairness to the people who want a flat Earth.
Yes, let's be fair to those people.
Okay. In Columbus's day, there was surely a flat Earth contingent. Okay?
Yes.
Columbus predates the era of experimental checking of any idea you might have.
Not a lot of peer-reviewed studies back in the day.
Back in the day. Back in the day.
Kind of just like
you just say whatever you felt.
You know what? I believe that elephant poop will cure cancer.
There you go.
That's right. Wrote a paper about it. Like to read it? Here it is. And you're good, right?
Right. So it wasn't until Francis Bacon, Galileo, in the 1600s, where the idea that if you're going to say something and you think what you're saying is true, then no matter how obvious you think it is that it's true, you should still test it.
Gotcha.
There could be something fooling you in one way or another. So if you want to say Earth is flat, then, for example, lunar eclipses. What's a lunar eclipse? If your face is the brilliant sun.
Thank you.
And this is Earth, and the moon is over here, the sun is always casting Earth's shadow into space. It's always there no matter what.
Right.
Obviously, okay? It's just a shadow.
It's a shadow.
The moon
it's just a shadow
occasionally
shining on blackness.
Yeah, a shadow in darkness.
A shadow in darkness.
So the moon occasionally passes through that shadow. And if you see the shape of Earth's shadow on the moon, it is always round. Always round. If Earth were flat, sometimes you get like a flat shadow.
Right.
We've never seen a flat shadow.
Right.
In fact, it is a segment of a arc of a circle, no matter the orientation of the moon and the sun. And the only thing that makes a perfectly circular shadow
would be something that's perfectly circular.
Perfectly spherical.
Spherical.
Yes.
And the only thing that makes a perfectly circular shadow
would be something that's perfectly circular.
perfectly spherical.
Spherical.
Yes.
And the only thing that makes a perfectly circular shadow
Would be something that's perfectly circular.
perfectly spherical.
Spherical.
Yes.
So the only thing that makes a perfect circle shadow every single time is a perfect sphere. Okay? No matter what angle
matter
you
where
shine.
you're shining.
Whereas a disc, it would only make a perfect circle if you lined it that way.
Right.
And then
you have to look at the face of the disc in order to get the circle.
The circle. If
If
any
you-
other angle, you get other shapes.
something of another
the
shape.
Greeks knew this.
Right.
All the lunar eclipses they said, oh my gosh, we must be in a round Earth. This is thousands of years.
Before
2,000 years
Columbus.
before Columbus. Exactly.
Many people think that modern astronomy's ability to accurately predict lunar and solar eclipses is a result and proof positive of the heliocentric theory of the universe. The fact of the matter, however, is that eclipses have been accurately predicted by cultures worldwide for thousands of years before the heliocentric ball Earth was even a glimmer in Copernicus's imagination. Ptolemy, in the 1st century AD, accurately predicted eclipses for 600 years on the basis of a flat, stationary Earth with equal precision as anyone living today. All the way back in 600 BC, Thales accurately predicted an eclipse which ended the war between the Medes and the Lydians. And as far back as 3,000 years ago, the Chaldeans, Egyptians, Indians, Chinese, and others accurately predicted eclipses to within seconds of modern methods. Eclipses happen regularly, with precision, in 18-year cycles, so regardless of geocentric or heliocentric, flat or globe Earth cosmologies, eclipses can be accurately calculated independent of such factors. Another assumption and supposed proof of Earth's globular shape, heliocentrists claim that lunar eclipses are caused by the shadow of their ball Earth occulting the moon. The idea is that the Sun, Earth, and Moon's spheres perfectly align like 3 billiard balls in a row so that the Sun's light casts the Earth's shadow onto the Moon. Unfortunately for them, this explanation is rendered completely invalid due to the fact that lunar eclipses have happened and continue to happen regularly when both the Sun and Moon are still visible together above the horizon. But for the Sun's light to be casting Earth's shadow onto the Moon, the three bodies must be aligned in a straight 180-degree syzygy. As early as the time of Pliny, there are records of lunar eclipses happening while both the Sun and Moon are visible in the sky together, and it continues happening during lunar eclipses to this day. In an attempt to explain away the inconsistencies in their theory, heliocentrists usually claim light refraction must be happening on a scale large enough to account for the phenomena. But even if this highly implausible, reverse-engineered damage control explanation is accepted, it cannot explain how Earthbound observers are supposedly able to see 12,000 miles, 180 degrees around a globular Earth to objects on the other side. The reality is, eclipses are a far more occult and mysterious phenomenon than lining up 3 billiard balls. Lunar eclipses only occur during full moons, when the moon is at the crossing point of the ecliptic opposite the sun, and solar eclipses only occur during new moons, when the moon is at the crossing point of the ecliptic and aligned with the sun. Such solar and lunar conjunctions and oppositions happen a minimum of 4 times per solar year, and depending on their exact altitudes and observer location, will produce partial, total, or annular eclipses. In ancient cosmology, these lunar nodes and accompanying eclipses were personified as the gods Rahu and Ketu, often shown devouring the sun or moon. During solar eclipses, the new moon conjunction directly crosses the sun, causing the blackout effect, and during lunar eclipses, the full moon opposition to the sun causes the shadowy red tint. This phenomenon is wholly celestial, involving the luminaries, and their regular interactions with one another, and not in any way terrestrial, involving the earth beneath our feet, causing upward casting shadows into the heavens.
So now if the Earth is round, how big is Earth? You might want to check for that. There was a famous experiment conducted by Eratosthenes. Eratosthenes. And there are two cities in the old world, and one of them, they knew that at 12 noon on a particular day of the year, that the sun was directly overhead and you could see the bottom of a well.
Oh, okay.
You don't run around looking at the bottoms of wells.
No.
Because the light doesn't take, it's just, no.
Doesn't get down there.
Doesn't get down there. How can we use this observation to see if Earth's surface is curved? We needed another well. Turns out we can't see the bottom of both wells at the same time. What might explain this? Well, there are two possible explanations. First, we could have a flat Earth with the sun that's small and close by, so that the light hits the second well at an angle. Or second, we could have a curved Earth with a sun that's big and far away, so that all the light comes in parallel, but only one well at a time is lit all the way to the bottom. Turns out with just two wells, there's enough wiggle room for both explanations to fit our observations. Eratosthenes only had two wells, but what if he had added a third? With a third well, it doesn't matter where the sun is. No flat Earth model can explain the angles of all three shadows, but the spherical model explains it all three angles, with ease. And to do this experiment, you got to measure the angles. Greeks had the angles.
Yeah.
Okay, in fact, geometry translates to Earth measurement. So one last thing, which should be obvious, if you pay attention and think about it. If you send a ship straight to the horizon, eventually it begins to disappear until it's no longer visible beyond your horizon.
Right.
And you should ask yourself, what kind of surface would produce that result?
The ocean,
The
ocean has a ramp. It's like a parking lot. The ocean has a ramp.
And it's an elevator.
It's an elevator. Then you get to a certain point, and they just like going down.
Seafarers knew this.
Right.
And so, however flat they would have imagined the Earth to be, they couldn't have accepted it to be completely flat, because otherwise you would never not see the ship. Okay. Also, if I just tell you, Chuck, walk due east, okay?
Right.
And don't ever stop.
Right.
I just turn around my chair and face this way, and eventually you're going to come back.
Right. And you'll probably be about 150 years old, because I am no Forrest Gump. That is how long it would take me to run the Earth.
For me, the fact that there's a rise of flat earthers is evidence of two things.
Okay.
One, we live in a country that protects free speech.
That's actually kind of awesome.
And two, we live in a country with a failed educational system.
Ooh, that one hurt. That one hurt. That one hurt.
Our system needs to train you not only what to know, but how to think about information and knowledge and evidence. If we don't have that kind of training, you'd run around believe anything.
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 And if you're interested in learning more about the Earth, the sun, and how the fact that we're hurling through space at, what is it, 17,000 miles per hour? Is that what we're going? Did
you just pull that number out of your...
I did. You know where I pulled it from. So you should consider all of this and consider checking out Brilliant, whether you are an adamant defender of the Earth's curves, or a professional scientist or a lifelong learner. Brilliant helps you master concepts of math, science, and engineering through solving fun, challenging problems. And you can sign up for free to get
And let's just go back and hear from the experts once again what's happening with the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
Again, based on that imagery that I saw looking 46 miles across versus 0.6 miles across, I really do believe, just like the expert said, the globalist guys, these are people who believe in the globe now. They are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing. I'm using the same logic that they're using, the same science that they're using. And, science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
Yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing, a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. And as with any scientific experiment, you always try to improve upon what you did before. So I got some foam core, made a little housing for the magnifying sheet, and pasted the city on the back there, and I made it as 2 separate pieces so that I could flex it as necessary, because I think that there are different types of atmospheric conditions that would allow for more magnification versus less magnification. So in this scenario you have more magnification, and in this one you have less. And for this one I decided to put the Toronto skyline into my little box here. And let's try it again. Okay, we're all the way up against the glass. Now let's zoom across the lake. And wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever. And this, of course, is my answer to the meme that you've all seen being passed around on Facebook, showing the missing part of buildings is absolute proof of the curve. No, not really. But, okay, here's the part I really wanted to show you guys. I was already in the process of modifying my experiment, so here's what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table, so the sun is always going to be parallel with the surface. And check this out. Alright, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification it does what we might expect it would. It gets smaller as it goes away from us. Alright, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size too. Pretty close. And of course, that's because as it's moving away, the magnification is still taking place. And so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about.
right now.
Low Earth orbit is between 99 miles and 1,200 miles away. The moon is claimed to be 238,000 miles away. That's a big difference.
This is the spacecraft that's going to take humans to explore the solar system. It's the next big step for NASA in exploration.
Called the Orion Multipurpose Crew Vehicle, or MPCV, this next-generation spacecraft will enable America to explore beyond low Earth orbit.
The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. Right now, we only can fly in Earth orbit. That's the farthest that we can go. What? Right now, we only can fly in Earth orbit. That's the farthest that we can go. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually. The moon, Mars, the moon.
Kinds of technologies that we're testing out on space station are definitely helping us with our goals of going beyond low Earth orbit.
Right now, we only can fly in Earth orbit. That's the farthest that we can go. Right now, we only can fly in Earth orbit. That's the farthest that we can go.
A set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
It was all recorded on these telemetry tapes. So where is this hard evidence?
I haven't seen anything that indicates the telemetry data is even in existence, and as I said, even if we had it, we don't have the machines to play it back.
But your own research has shown the telemetry data is missing.
That's right.
Could this be true, mankind's first interplanetary exploration, and the original science data is missing?
11, this is Houston, radio check, over.
If it's anywhere, it should be here at NASA's Goddard Space Center in Maryland, home to the National Space Science Data Archives.
This film you're making now, what is it?
This is a film trying to prove that Apollo 11 happened.
Does it have a name? I mean, do you have a name for it yet, or are you?
I'm calling it Did We Go?
Did we go? Okay.
Doesn't have it either. The Smithsonian doesn't have it. Johnson doesn't have it.
Right. We've been unable to track it down. I mean, we don't know where this telemetry data ended up, and we don't know what path it may have taken. So, unfortunately, I'm afraid I can't really give you much of a clue as to where this data ended up and whether it still exists or not.
Closer look at the supposed two images provided from NASA of Jupiter. Here's the problem again, 2016, 2014. What's the difference here? Well, the difference is they added the supposed auroras on the north and and this is nothing but a Christmas tree. Give me a break. Take a look here. I mean, all the clouds are in the same exact position. Just the 2016 image is a bit, I would say, darker. It's a bit lighter in 2014. Here's a side-by-side. People can't see what's taking place here with NASA. Nothing more than fakery. I mean, give me a break. This is a complete insult if you have a brain in your head.
So I keep digging a little bit deeper, and I finally get underneath this cloud cover here, and a few images pop up. And I say, oh, images, what are they? Well, this is what you got, which I'm sure that looks familiar to you, right? Looks just like the pictures they give us of Mars. So I'm just kind of creeping around here and definitely noticing the same kind of undulation changes and same kind of rock, same kind of dirt. The only thing that's missing is that nice little red tint that they pay somebody $150,000 a year to put on there, right? Whose orange Hummer is this? Okay, that looks like a NASA symbol. Well, let's dig a little further because I can't really see anything on here other than it certainly looks like a NASA symbol. And I can't read that. Tried. Cameras set up, tents, ATVs, food. They've been there a while. It's not a one-day trip. Antenna set up out in the middle of nowhere in Greenland. Another ATV, a leveler equipment. So I'll keep kind of going through here and see if it. What the? Yeah. So I think I found out where Mars is, guys. It's just about 1,000 miles north of me. Not quite the distance that NASA says, but I can't find anybody who's in charge of this. They must be hiding behind these rocks. Oh no, there they are out in front of everybody, standing there. Lovely. Cloud number 1, cloud number 2, cloud number 3. This thing's just driving around taking pictures.
Simmons' job is...
It's primarily taking data and making pictures out of it.
That's what this is. A composite of data sets from several different instruments translated into a picture.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, looks kind of flat, looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
English in reading too much, but I've since grown out of that and I enjoy reading now. And I played a lot of sports. And all of that happened in a little town called York, Maine, across the United States from where we're talking to you right now. Across the United States from where we're talking to you right now. Across the United States from where we're talking to you right now.
And let's enlist the help of a friend, Paxi. You might know her.
Ladies and gentlemen, if you didn't figure out by now, I'm going to be the first man to actually tell you this, that teleportation is officially real. We are live in the ISS, and let's go back and relook at that clip again. You see? Now watch. Oh, wait. See, this, ladies and gentlemen, should let you know that this is only done through the usage of chroma key. This is chroma key technology. This is green screen or blue screen technology. That's what is being utilized here. This is simply virtual reality that is actually being fed to you, and you're taking this virtual reality, making it the reality. When in fact, all this is simply just virtual CGI, computer generated images. So you decide for yourself. If we have the technology to build the space station and have people go and live in the space station for months and months at a time, and they are there constantly reporting back to Earth the things that they are finding there, then the question is, why go through all this trouble as far as faking the space station itself? Why go through the trouble of faking these people in space who are supposed to be the astronauts who are in space and have their arms disappear from the screen just like that? Why have that? Why go through all that trouble?
Ed White is flying at 17,000 miles per hour, 200 miles above the Earth.
Okay, I'm out.
If the spacesuit fails, the difference in pressure will kill him instantly.
This could be a serious problem because you don't want your stop-motion toy to die in space.
As White floats in space, a glove drifts out of the capsule.
Oh, so a garden glove floating off makes it real? You're telling me there's an astronaut in space with no glove and a bare hand exposed? And what blew it away? The wind?
Today, those pictures are classic. They're still overpowering today to realize, number one, it's been done, and that we did it. It blew me away.
How easy it was to deceive everyone. It was quite easy, actually. I know what you're thinking. So, NASA is fake, big deal. How does this affect me? Blah, blah, blah. Or you're thinking, no, there's no way my heroes could be lying to me. There's no way that this whole world is in on this big scam. This is just too much. And that's what I would have thought too. But here is what they are hiding and why NASA formed in the first place. Pay attention.
Down at the bottom of the world. A number of expeditions that will follow, I think, year after year, at the bottom of the world, because the government has really become interested. I tell you one reason they're interested. It's by far the most valuable, important place left in the world for science. That's why the scientific groups all over the nation are really interested. But more important than that, it has to do with the future of the nation, those to come after us, or even during your lifetime. Because it happens to be an untouched reservoir of natural resources. You know, as the world shrinks with an ever-increasing acceleration, far-flung places once useless, like we thought the North Pole was, and no man's land, become very useful. The bottom of the world will be important, not only to us, but to our allies. And it's the most peaceful place in the world.
Well, I'm sure that won't last very long. What are the natural resources there?
Well, we've found enough of coal within 180 miles of the South Pole in a great ridge of mountains. It's not covered with snow, enough to supply the whole world for quite a while.
Well,
that's the coal. Now, there's evidence of many other minerals. We are pretty sure there's oil. Now, that coal shows the bottom of the world. Now, by far the coldest spot in the world. Where that coal is gets 100 below zero in the winter.
Well,
it was once tropical. So we think there's oil there, and there's evidence, probably uranium there.
Is it any secret? Is there uranium there? That would be the only thing that would be practical to actually go after, I suppose. Everything else would be economically unfeasible, wouldn't it?
Well, as we recklessly expend our resources, the time will come when we'll have to go after that stuff down there.
Well, Admiral Byrd, are private expeditions a thing of the past? Is expedition and exploration, making expedition and exploration now purely a government function because of the tremendous cost
No, I
and
don't think
organization?
so. I think down south it may be more or less a thing of the past, but not other expeditions that go there. A lot of them go north now. The North Pole is the center of an ocean 10,000 feet deep. The South Pole, the center of a plateau 10,000 feet high.
I found something very interesting. Since I'm a big fan of NASA, I like to watch many of their videos. Today I was watching this old footage from the Challenger mission. I was thinking I need to stop spreading this flat earth bullshit because maybe NASA is legit and maybe all their missions are real. Watching NASA videos is a good way to make yourself believe it's all real. Unless you find stuff like I will show you in a minute. Maybe other people found this already, I'm not sure, but I am sure that I never saw this before. So, when you look at this footage, sometimes it kinda makes you think, was it all real? Is it all real? Cause many parts of it kinda look real. Like the part where you see all the people watching the rocket, like this part. It's kinda hard to fake it and it kinda looks very real, so the rocket probably was real. But then, well, just let's keep watching, it will show up in a minute. This video was uploaded by the International Astronautical Federation, and like a good reporter or a good journalist, I checked my sources and this is what Wikipedia told me. It's an international space advocacy organization based in Paris and founded in 1951 as a non-governmental organization. But it's full of governmental people. But that doesn't matter. It's uploaded by them. I will link the video in the description so you can all watch it. And maybe you can put some comments on the original video, but please be polite.
Running properly. The next scene you'll see from the cockpit is when the solid rocket boosters departed, and that was really a bright flash.
This is all showing the rocket from the Earth going to space. This is the real part because it is real. But now the rocket is getting into space, so now the fakery comes in. This is the time when you watch the recent rocket launches. This is when they switch to animations. But back in the time there was no software to make animations, so they had to do something else to convince you that the rocket is in space. These days they just use cartoons. It's kinda insane that people believe cartoons. Do you wonder how they used to do it 30 or 40 years ago? Do you remember Thunderbirds? That basically shows it. It's just a bunch of tiny models in a dark room with some special effects. But at least Thunderbirds did a decent job, because in Thunderbirds you never saw a guy in the background showing up. So this video is an astronaut explaining the mission. It's not like practice footage or anything. Watch closely.
Arrangement. Dan sat in the pilot's seat during this operation, sort of monitoring the motion of the vehicle, making sure that it was steady and that there were very few vibrations of any sort. This is a picture of the INSAT actually being deployed from the spacecraft. You can see that the deploy went very smoothly. At the moment of deployment...
Did you see it? In the background? There was a guy in the background, man. I'm not kidding you. You can't deny that that's someone in the background. There's a guy moving in the background. Here, watch it again. Watch it closely. I looked up, or I tried to look up the size of this rocket. I found this picture. You can see it's massive. So if that rocket is in space and if there's a guy in the background in that footage, that means that there are like giants, but like insane big giants floating around in space looking at NASA. That's probably why they don't dare to go back to the moon and why they hide so much stuff. Space is full of giants. Well, NASA, this video was a lot of fun to watch. There's a lot of weird things in this. Let's keep watching a bit more of this.
About a minute 20 seconds after deployment, you can see some of the jets on the spacecraft.
Here you can see how they switch on the light of the Earth. It's kind of funny, isn't it? How do you explain all this shit? But at least you can see that the Earth is a ball. At least they are not hiding the shape of the Earth. Or maybe is it a fisheye lens? Oh, the satellites start to spin for the video. Well, at least we see it's a ball, you know. It's even more a ball when it goes down. And it doesn't look like it's in outer space, it looks like high altitude at most. These old videos are a lot of fun to watch.
Genesis chapter 2 verse 1 reads, "Thus the heavens and the earth were finished, and all the host of them." So all the host of them, if you believe in the globe model, would include the universe. So it's done, right? But if you believe the earth is a globe spinning through space, it's not done. You have to believe that the universe is ever expanding. That's why it's spinning through space. That's why our galaxy is constantly, according to science, traveling through space, because it's expanding into nothing. But God says, we're finished. Everything's finished. Everything's done. There's no more creating happening. There's no more expanse happening. It's done. The heavens and the earth are finished, and it's an enclosed system. And it's all right here.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go. One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before. It can take astronauts deeper into space than we've ever gone before. It can take astronauts deeper into space than we've ever gone before. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Extreme radiation. We are headed 3,600 miles above Earth. 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
Any ill effects from the Van Allen radiation belts?
No. Now, I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did. I don't know the distance to the Van Allen radiation belt.
We are headed 3,600 miles above Earth. 15 times higher from the planet than the International Space Station.
Any ill effects from the Van Allen radiation belts?
No. Now, I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did. I don't know the distance to the Van Allen radiation belt, and if we did, it wasn't a problem.
We must solve these challenges before we send people through this region of space.
If we were going to encounter it, then we would have had to build the spacecraft and the spacesuit to not give humans a problem.
We must solve these challenges before we send people through this region of space.
You don't just build something and hope it works. You study to see what the threats are, the environment is, and then you say, how thick do I have to make the metal on the spacecraft so that going through this kind of radiation or these kind of meteoroids, it won't get hurt. And then we build it that way.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation.
And we didn't get any, added radiation.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
We must solve these challenges before we send people through this region of space.
Then we went right out through them.
No effects on your cells?
We didn't even know it.
An area of dangerous radiation.
But I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside.
Shielding will be put to the test as the vehicle cuts through the waves of radiation.
Well, maybe somebody said you went through the radiation belt, but we didn't feel it inside.
Shielding will be put to the test as the vehicle cuts through the waves of radiation.
And we didn't get any, added radiation.
No effects on your cells?
Didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside.
Area of dangerous radiation.
And we didn't get any, added radiation.
I know there's a strategy. I know you're coming back with reinforcements, something. I know there's a plan. You can tell me no other human will ever know.
There is no plan.
We were hidden in the first booster rocket to separate. Splashed down back in the Atlantic just as planned. We ain't going nowhere.
construct is echoed through all hubs of the system. It's everywhere. Everywhere we look, this construct stares back at us.
In case you find these videos useful, please share them with others so we can help them too. Subscribe and hit the bell icon for more videos and updates. Thank you very much for watching. See you next time. Peace.